Hey everybody, what's up? What's up? Welcome back. Dr. Jaws here, and happy St. Patrick's Day. St. Patrick's Day 2025, and tonight we are talking about some Irish sharks, but mostly the Pygmy Shark, Euprotomicrus bispinatus. Before we get started, just want to shout out, hey Howard, how are you doing? Happy St. Patrick's Day to you. I just wanted to shout out your artwork for the hook-tooth shark, Counter-illumination, macrostoma, and I'm trying to figure out the display on this. I don't know. This eCam update has been kind of weird on my computer. There we go. Okay, there we go. This is better. So I've been trying to make sure that I can actually display this in a way that. Okay, let's see if this works. There we go, so that we can get a good view of it. But this looks really cool. This was for a species that we covered. Sorry about that. That we covered a few weeks ago. But this is a really cool piece of art, and I just wanted to draw attention to it. I posted it on the channel page, but thank you so much for submitting it. It's an extremely cool species with such a unique dentition, and that was a really fun stream that we had for the hook-tooth shark a couple of streams ago. I think that's stream 107. Let me double check, but I love the shape, just kind of how do I say it? Kind of the movement that you capture as far as it's kind of more like a sinusoidal movement for this species, and it really captures, that these sharks, this group of sharks, this family of sharks, is not really the robust Carcharodontidae, but it's also not the super elongated Muscelidae. It's kind of in between. So it's super cool and such a unique group. So thank you so much for your art. And actually, there's a lot of cool stuff that we're going to be talking about tonight on tonight's stream, shark-related. And I know you're a huge fan of fossils, Howard. There was a very interesting fossil discovery that you might have heard of, but it was in Mammoth Cave. And yes, hook-tooth shark was stream 107. So I just wanted to shout out if anyone, for future viewers, are curious about the species in the picture here, the hook-tooth shark, please check out stream number 107. So we did that a couple weeks ago for the species. So thank you so much, Howard, again, for this beautiful piece of art. I really, really love this work on this species. So, but there was an interesting discovery. Here we go. New shark species at Mammoth Cave National Park, and I believe this is in Kentucky? Yes, Kentucky. So, Mammoth Cave National Park. And I think this might be it. This animal right here. Why is this? Okay, here we go. Okay, Clavosodens is this stripy animal right here. So this is the species that was discovered, and apparently there we go. That's a better view of it. So apparently this area also has fossil, it's a famous site for other prehistoric shark species, but I just want to take a moment to shout this out because this actually was literally a couple days ago. So, and I'm curious if this is a shark or a chimera, because a lot of the ancient shark-like animals were actually chimeras. So we'll check it out, but here we go. A new to science species of ancient shark has been discovered through an ongoing paleontological resource inventory at Mammoth Cave National Park. The new species of Orprechi. Oh wow. Hold on. I'm usually pretty good at this. Obruchevodid petalodont. Abruchevodid. Abruchevodid. Okay, Abruchevodid petalodont. There we go. Okay. Called Clavosodens mcginnesi, was identified by researchers through fossil teeth collected from deep inside the St. Genevieve Formation within Mammoth Cave. Oh yeah, yeah, agree. Wild recreation, and actually, it's kind of amazing where this is unlike any. There's a lot of features of this animal that are unlike any chondrichthyon we've seen so far. Oh, cool. Petalodonts are chimeras, I believe. Interesting. And that makes sense. So you have kind of the boxy head, kind of like a chimera, which is compressed a little bit. I guess you would call that laterally compressed. So it has like the boxy head like a chimera. The eyes are very high on the head, a little bit like a heterodontiform shark. You've got these really cool like chin, or not chin, kind of like cheek spines. You have a jaw that almost looks like it has fused teeth a little bit. But then look at this. You have a pyramidal shape, a little bit like the rough sharks, and yet this undulating fin that is reminiscent of a ray. And then what's even wilder is that these two, I can't tell if these are claspers or if these are spines that extend way beyond the pelvic fins. And then this rounded caudal fin. So this is an amazing looking animal, and it's unlike any modern shark that we know today. So this is super cool. Let's see. The fossil discoveries in Mammoth Cave to continue to reveal a wealth of new information about ancient shark species. Researchers and volunteers collected samples from the main Mammoth Cave system and from smaller isolated caves throughout the park that provided new data on previously known ancient sharks and revealed several species that are brand new to science. These discoveries help scientists better understand the relationship and evolution of modern shark species within this relatively small geographic region. So it's like exactly, Howard. It's like a shark body on top of a ray body. So I thought this was so cool, especially since this is brand new. So Clavusodens McGinnessii, or McGinnis's nail tooth, was discovered from a number of small teeth found throughout the St. Genevieve Formation rock layer in Mammoth Cave National Park. The name is derived from the shark's back teeth, which superficially look like old iron nails because of their flat crowns and long tooth bases. Interesting. Nicknamed chipmunk sharks. Oh my gosh. A chipmunk shark. Never in my wildest dreams could I imagine a chipmunk shark. Where is Mammoth Cave? So Mammoth Cave, let's see if we can get the map. Mammoth Cave is in Kentucky, and actually, so I am the oldest of three brothers. My youngest brother actually has been to Mammoth Cave, and it's supposed to be a really beautiful park, but it is in Kentucky. Let's see. So Mammoth Cave National Park is a huge complex. Let's see, on I-65. like I know where that is, because I don't really travel into the interior that much. I'm usually, as far as the United States goes, I've been up and down the coast, from Maine to Florida. I'm trying to think of all the states I've been to, but okay, so yeah, this is really like dead center. Oh, this is cool. This is actually all the national parks, but yeah, so this is like kind of dead center in Kentucky, right here. So I'm just kind of curious where I-65 connects to. Hold on. Oh. Okay, so from Canada, it would be, you have to go past Indianapolis. Yeah, it would be a very long drive, so flying would probably be better, but, oh, cool. I know some petalodonts are found in Montana. Interesting. That's actually really cool, and that's incredible, because, like, when you compare on the map, petalodonts from Mammoth Cave in Kentucky, and then petalodonts from Montana. So that's a huge geographic area, and it's kind of amazing to think about, like, just how the continents like have shifted as far as were these areas a bit closer, or is this indicative of I forget specifically the geology of what I mean. So much has changed, like this long ago. So much has changed, but let's see. I'm trying to think where I've been. Now that we have a map of, I actually have not been to a lot of national parks, but I've been to, let's see, Washington, Oregon. I've been in an airport in California, but I don't really count that. Ohio, Florida, Georgia, South Carolina, North Carolina, Louisiana, Virginia, DC, Maryland, Pennsylvania, New Jersey, New York, Connecticut. I've not been to Rhode Island, Massachusetts, New Hampshire, Maine. So I'm mostly on the East Coast. East Coast, a little bit of the Gulf Coast. Oh no, I hate this. Sorry, okay. We gotta get back to it's the Gulf of Mexico. It's the Gulf of Mexico, people. That's insane. So, boo, 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 boo. I want to get back to, let's check out the IUCN Red List map, because IUCN Red List is gonna have this correct. So that's a shame. But, yeah, just the reason, like, I harp on that is the scientific community will always call it the Gulf of Mexico. Shark lovers will always call it the Gulf of Mexico. So I just want to emphasize that. So there we go. Yeah, IU's Amaryllis still refers to it as the Gulf of Mexico, as it should. So, oh my goodness. But anyway, that park, though, is a really beautiful park. My brother has been to it, and it is famous for a lot of fossil formations, including this one. So these are really cool sharks. This is actually also from Mammoth Cave National Park. So here we go. 2 new to science species of Stenacanth shark fossils. So these are famous sharks. Stenacanth shark fossils. Oh, thank you, Howard. Yep, yeah, absolutely. I'm going to star that comment. Thank you. 2 new to science species of Stenacanth shark fossils have been discovered through the ongoing paleontological resource inventory at Mammoth Cave National Park. The 2 sharks, Troglocladodus. I'm usually really good at this, but the fossil sharks are tricky. They're tricky for me because I'm used to modern sharks. So Troglocladodus, Trimblei, and Glycmanius cariforum, probably cariforum. Okay, Glycmanius cariforum were identified by fossils collected from Mammoth Cave in Kentucky and northern Alabama. Let's see. Every new discovery of Mammoth Cave is possible due to collaborations. Our park team is honored to work alongside the National Park Service Paleontology Program and now the University of Alabama Geological Sciences Department. Whose coordinated efforts have made this latest announcement possible. Troglocladodus trimblei is a new genus and species of shark that was identified through adult and juvenile teeth found within the St. Louis and St. Genevieve formations of Mammoth Cave and the Bangor Formation, Alabama. The genus name means the cave Cladodus, or cave branching tooth. It's named in honor of Park Superintendent Barclay Trimble, who founded the very first specimen, a single tooth, on an early PRI trip in 2019. These are new species. I think troglodyte repronunciation. Troglodyte. Oh, cool. Troglocladodus. Oh, that's actually really cool. Good call, Howard. That is awesome. That is Latin in action. That is super cool. Perfect. That's exactly it. That is so cool. I also love, that kind of reminds me of I love that troglodytes are actual animals. Like it's, because, in common parlance it means like a profoundly ignorant person or like creepy cave monster from like a horror movie. But it is actually, in science, it's referred to a group of animals that live in a cave ecosystem. So, and they're not phylogenetically linked; they're ecologically linked. So, like isopods or like cave fish, those are both troglodytes, just because they actually live in caves and they spend their entire lives in caves. I don't know if bats would be counted as troglodytes because depending on the species, I don't know how many bats are actual like completely cave dwelling bats. I'm sure there's quite a few that probably are completely cave dwelling. The bats that we have here, they are tree dwelling. So they're small, fluffy, furry, or chimney dwelling, like myotises and eastern bats. So, which I really love. Whenever you go hiking in an evening in not just Virginia, but I think in the kind of in the Mid-Atlantic region, probably just the entire East Coast, you can see bats kind of like flying past your head and like looking for bugs. So I really like it. I think it's really cool. But oh, cool, Howard. Ours go out at night. Very cool. So let's see. The Troglocladodus is estimated to have reached about 10 to 12 feet in length, or about the size of an oceanic white-tip shark. Super cool. The second shark, Glycmanius cariforum, is a new species of Glycmanius that pushes the origins of the Stenacanth back over 50 million years earlier than expected. It was identified primarily from teeth in the St. Louis, St. Genevieve, and Hanley formations at Mammoth Cave and the Harstel and Bangor formations of Alabama. Partial set of jaws and gills in young Glycmanius were also found at Mammoth Cave. Oh, wow. Howard, our cave bats carry rabies. Ooh. Yeah, actually, I think here, so the incidence of rabies is high in bats, raccoons, and I want to say skunks here. I could be wrong about skunks, but for sure raccoons and bats. Those are we have that kind of concern as well. So yeah, so it's like I'm kind of randomly thinking about because I mentioned before I'm a big Indiana Jones fan. There's a weird scene. I love Temple of Doom, but that movie has a lot of problems, including there's a weird scene where they're hiking through the jungle in India, and there's all these fruit bats, these giant fruit bats, and I guess Steven Spielberg thought it would be cool to call them vampire bats, and they're not. Vampire bats are very small, but yeah, that's just like that movie's awesome. I love that movie, but like it's got a lot of problems, and that's one of them. So just randomly thinking about that. Just fruit bats are harmless and huge and eat fruit. So. And I don't think we don't have, I don't think we have any in, I think we do have some in Mexico. I don't think we have any in the southern United States. I could be wrong about that, but anyway, sorry, bats are cool. I think they're really cool. So, let's see. Okay, here we go. Sorry. The set of cartilage fossil from Glucomanius was the first of its kind in this genus of Seneca shark. Species was named in honor of the Research Foundation. Glucomanius cariform is estimated to reach 10 to 12 feet, length about the size of a lemon shark. Its jaw shape suggests it had a short head with a powerful bite for eating smaller sharks, bodyfish, and squid-like orthophones. The two sharks identified would have hunted the ancient nearshore habitats that covered Kentucky and Alabama over 325 million years ago. So checking our timeline, 325 is Carboniferous period. So that is wild. So, oh yes, thank goodness that they are harmless. So, but Carboniferous sharks, that's why it's incredible like how old that is, because here we have Miocene sharks, and that's barely even like that's incredible to think about Carboniferous sharks being sharks that predated the dinosaurs. It's unbelievable. So, let's see. At least 70 species of ancient fish have been identified at Mammoth Cave from over 25 caves and cave passages that have been surveyed. That is so cool. Let's check out. I'm actually kind of curious about this link. Sorry, the audio is fuzzy. Oh, thank you. Awesome. Audio is okay now. Sharks in the Dark Paleontological Resource Inventory reveals multiple successive Mississippian subperiod cartilaginous fish assemblages within Mammoth Cave National Park, Kentucky. Let's see. Okay. So I do want to read this because I do think it's interesting, and Sharks in the Dark might be kind of a fun segue to our Pygmy Shark, because it is a bioluminescent deep sea shark. So I think it'll be kind of cool to lead in with this ancient shark, and then we'll talk about the Pygmy Shark. So a focus search for ancient Mississippian sub-period marine vertebrates during a paleontological resource inventory of Mammoth Cave National Park, Kentucky, has yielded a wealth of new fossil data previously unrecognized at this park. To date, we have identified marine vertebrate fossils from 4 primary horizons of the park, 2 of which are the first records of marine vertebrate fossils occurring in those horizons. Mammoth Cave sites have produced more than 70 species of ancient fish, about 90% representing cartilaginous fishes, sharks, and kin, including several new species. The Paleontological Resource Inventory of Mammoth Cave demonstrates that this park is an important resource for providing data on how fish assemblages changed during the formation of the supercontinent Pangaea. The inventory data can also help correct antiquated information on fossil sharks found in the region, in some cases not updated since their publication in the late 19th century. So this is really cool. Let me see if I can get this. There we go. So just a better view for everybody. This is really cool and stuff that I'd be so nervous about doing. So we actually have some caves in the mountains of Virginia. The famous ones are Luray Caverns and Skyline Caverns. I have been to both, and I actually did go to Skyline Caverns last year. So, like, caves like that are very safe, and I'm sure Mammoth Cave is very safe. But like, let me know what you think about caves. I'm a little creeped out by being underground. Like, I'm happy being underwater. I'm not so happy being underground. I think it just freaks me out a little bit. But looking at these cave explorers, this looks really cool and just a little freaky. But let's see if we have any shark images. I hope we do. Oh wow, okay. So this is a really cool. I'm gonna put this in the chat so that because I'm sure, you know, we have viewers who'd love to read this because this is an extremely cool study. Let's see if I can zoom. Hold on. Perfect. Okay. Just want to make that big enough. Okay. Because this is strata of sharks. So here we go. So these orange ones. So these are color coded by group, I want to say. Wow. Okay. Yeah. Let's see. Okay. Good. Okay. So orange are stenacanthiforms. So stenacantha. Hey, Vivia666, welcome back. Oh, you started. Oh, it looks like every week. It looks like you started an hour earlier. Sorry, I promise it's 9 o'clock East Coast time. However, that's actually a good segue. So I do have a question for the chat, and nothing is set in stone yet. But I'm actually considering potentially rescheduling the streams to Sundays at 9. So let me know what you guys think. I've not made a decision on that yet, but you know, because they're currently Mondays at 9. I mean, they've always been Mondays at 9, and that's been a really fun time. Like for me personally, and I think for our community members, it's been a lot of fun as well. But I'm actually kind of weighing, you know, would Sunday be better? You know, so I haven't made a decision yet, but because I want your guys' input. But let me know, and actually. Let me type that in the chat too. And I'm going to put this on the YouTube community page because if it is something that may change, I would want to kind of roll it out over the course of weeks, you know, so just to kind of get used to it. But yeah, would Sundays at 9 p.m. be better for the stream than Mondays at 9 p.m.? Okay. Let me know what you guys think. And I haven't made a decision yet, but Bibby, your question kind of made me think about that, so I've been curious about it. Let's see. So we're still in wintertime, you're summertime, and no to Sunday because Monday I work and Tuesday I start late or I'm free. Okay, so Bibia does not like Sunday. Totally understandable. For me, it could encroach on family dinner, but I could probably work around it. Okay, so it sounds like we probably want to stick with the Mondays, and I think we can. And part of like me, when I started on Mondays, I think part of it is just understanding that like this is a long stream on sharks and shark science, and it might not like on a weeknight. It's kind of fun because you know like throughout a typical work week, it's kind of like. You know, a nice little distraction. But on the weekend, I know that time is precious. And for anybody, like for example, in the U.S., like who likes football, Sunday night football is a big deal, and so that's kind of not something probably people will want to do. But yeah, I appreciate you guys' input. I think we'll probably keep it on Mondays then. But I was just kind of toying around with this idea. Yeah. But I think we'll keep our original Monday time. So, but thank you for your input though. I really appreciate the feedback. So. But anyway, this is a really cool study, and let's take a look at, in detail, the members of this fossil assemblage. So in orange, we have this stenacanthiforms. In blue, we've got pedalodontiforms. Purple is holocephaly, so these are, you know, like modern chimeras. Light blue is eugenodontiforms and orodontiforms. Now... I'm trying to remember. Oh, and red is Eucelachi. This is actually really cool. Wow, there's actually a lot going on here. So, okay. So Stenacantha is the orange sharks. They're very famous sharks. The holocephaly, the purple, are chimeras. the red, the Eucalachi, are modern sharks. So this is actually really cool to see where in these formations, you've got... Let me see if I can get on my phone the breakdown of these formations, like their actual timeline. I really wish they plotted it against, actual years. So let's see. Mammoth Cave formations timeline. Okay. Okay. Hanley formation. Okay, good. Okay, so these are all apparent. Okay, so these seem to be all Mississippian? Joppa, Fredonia, Greenville formation. Okay, so these are all 320 to 360 million years ago. So the formations on the top are more recent, and the formations on the bottom are deeper. Older, much older in time. So, and it's kind of interesting because on the ones on the top, you don't have modern sharks here, but when you go further down, check this out. So this formation, the St. Genevieve formation, has a bunch of specimens, including the red ones right here. These are Eucalachi, which are true sharks, or modern sharks. So these are the ancestors of the sharks that we know today. And it's actually kind of wild and kind of freaky to see that, where the red sharks are the ones that have evolved into our modern shark species, and then everything else is just different. So the cenocanths are huge and just completely different group of sharks. Again, the chimeras, the holocephali, are in the purple. So this is actually a really amazing breakdown of all these different individuals. So let's see. Interesting question. So chimeras are actually, they're not sharks. They are different, and it is really confusing. That's a great question, Bibia, because it actually that is a fantastic question, because scientists have debated this terminology, and it's you have three groups of chondrichthyans. You have the sharks, the rays, and the chimeras. And some scientists, and I don't think they're the majority, but some scientists have termed rays as flat sharks and chimeras as ghost sharks. So sometimes on nature programs, you'll see people looking at chimeras and calling them ghost sharks, or looking at rays and calling them flat sharks. And I personally don't like that. And I think the majority of scientists don't really like that either, because sharks are sharks, and chimera is old, but chimeras are it's just they're a different group, because what makes a shark is it's an animal with its gills on the side of the head. Its fins are not attached to the head, the fins are separate from the head, whereas rays have their fins attached to the head. A shark's jaws are beneath its eyes, and forward facing. Yes, Howard is right. They are all cartilaginous fish, but they're kind of different kinds of cartilaginous fish. A good analogy is it's kind of like saying okay, so it's kind of like saying so dogs and cats are both carnivores, but it's kind of like saying cats are angsty dogs, or dogs are lazy cats. Like that. That's why it kind of bothers me, because it's well, no, they're really different things. Dogs are their own thing, and cats are their own thing. They're both carnivores, but they're just different kinds of carnivores. And that's the same thing. Sharks are their own thing, rays are their own thing, chimeras are their own thing. They're all cartilaginous fishes, but they're just different kinds of cartilaginous fishes, if that makes sense. So it's a really great question, and it is confusing because, again, scientists do some scientists and some conservationists do refer to rays as like flat sharks, or chimeras as ghost sharks, but they're really, I personally keep them separate, because they're just so different. Like chimeras actually don't even have exposed gill slits. They actually have an operculum, kind of like a bony fish, covering their gills. So they just look very different. So it's a fantastic question because it does get really confusing. But for me and for the sharks that we talk about on the stream, this fossil chart is a really good visual. The sharks that we talk about the stream are the red ones here. So these red sharks are part of Euprotomicrus, which is Latin for true sharks, and these are the sharks that evolved into modern sharks. The orange ones, the green ones, the yellow ones, these all died out and went extinct. And then the purple ones, these still exist as chimeras. So these are the holocephali, which became the modern, and they're still the group of chimeras, but these are what the chimeras have evolved from. So the purple is still here with us, the red is still here with us. They're two different groups. Everything else is extinct. So, but that's a really great question, though. So I really appreciate it. And Howard, bear in mind that different layers have different preservation levels. That's a really, really excellent point. So yeah, this is really, really cool breakdown. So I put this link in the chat for future study, but it's really, really cool. And also, look at this. The paleogeographical environmental reconstructions of the Middle Mississippian of Mammoth Cave National Park region. So A is a paleogeographical map of the North American region of Laurentia subcontinent before the formation of Pangaea. So that is so cool. So this is before Pangaea. So Laurentia and Gondwana were the two major continents. And I actually want to say, and I could be wrong about this, but I want to say that when Laurentia and Gondwana combined, let me make sure I got this right. They might have made the Appalachian Mountains when they combined, but I could be wrong about that. So let me make sure. Appalachian Mountains. When do these form? Formation. Because Appalachian Mountains are extremely old. Geology. Oh, maybe not. Maybe not. Okay, the continents that were ancestral North American Africa collided during the formation of supercontinent Pangaea. Okay, because North American Africa were once geographically connected, the Appalachians formed part of the same mountain chain as the Little Atlas in Morocco. Interesting. Okay. So, I think, yeah. We are 100 million years ago, yeah. Yeah, so I could be like 350. Yes, we are 350 million years ago. So this is super, super old. This is before the Jurassic period, before the Mesozoic era. Sorry, I keep saying Jurassic because it's like Jurassic Park, very famous, but like Mesozoic era. So this is pre-dinosaurs. Also, I really love dinosaurs as like a handy touch point of like how old something is. So if it's before the dinosaurs, it's like, oh my gosh, it's ancient. But here's what it looked like. This is the ecosystem. So this is the ancient seas between those two continents before Pangaea. So what we have here, we've got there's Glycmanius. So this is one of the new sharks that was discovered. Cladotis, Cyvodus. Man, there's so much going on here actually. So. Yeah, that's a really cool comment. When shark really wasn't shark yet. Yes, because modern sharks... you know what? Let's look that up. Because the oldest sharks would be Devonian. But Eucylachii, the modern sharks... Let me see when they rose. Shark-like chondrichthyans first appeared in Devonian period 419 million years ago. Oh, Howard, sharks go back probably to at least 450 million years ago. I'm curious when the modern sharks arose. The earliest confirmed modern sharks, selachomorphs, are known from the early Jurassic around 200 million. So that is so cool. So cool. So yeah, these are definitely before. So to Bibia's point, these are definitely before modern sharks. To Howard's point, these are still the group that evolved from the oldest known anything resembling like a shark as far as the jawless. Jawed fishes go. So it's so cool. And look at the diversity here. And it's kind of amazing. This shows you how like rich of a site Mammoth Cave is. So I gotta go someday. I mentioned before my brother went, so I hope he took pictures. I'm gonna ask him if he took pictures. So, because like that's honestly unbelievable, and it's really cool to see. And also, look at this illustration here. That looks like a modern 6-gill shark, right? Like just like the broad head and everything. So it's just so cool how conserved the evolution is. So there are scales from the Silurian and possibly Ordovician. Oh my goodness. That's unbelievable. That's so cool. Let's see. We've got more details on the fossil formations, but I don't want to. I just want to kind of skip ahead. Oh yeah, Nasto something jawed. Yep. That's is it Nathostoma? Or Nastostoma? I think I know exactly what you're talking about. I think it is Nathostomes. Is the beginning of that. So very cool. So here are some of the actual fossils from Mammoth Cave. Okay, we got Meckel's cartilage at the top here. Cranial cartilages here, teeth here, shark spine. This is super cool. And look at these. I don't think I've ever seen teeth remotely looking like that as far as like the actual composition. The tooth shape is similar to modern sharks as far as like, you have a central cusp, you have little cusplets, but look at the rock formation. Like these are so cool, and like they look so like, I mean, it sounds dumb, but they look so worn. Like they look like actual like almost kind of like an ivory texture, which is so interesting. Like just these like striations, the discoloration. These look so different from shark teeth fossils that I'm used to. So it's super cool. This is a really fantastic collection. So, and that's something I really love. It's like, I'm so focused on like our coast. How old is this? This would still be the same time period as the Carboniferous. So this is 300 and this is probably 350. Let's see. The St. Genevieve Formation is, Howard's right, 360 million years ago. So it's really cool because it's like I'm so used to, it's like, so I'm in Virginia and Virginia borders Kentucky. So I'm in Virginia and we have a lot of modern sharks, like about 54 species. If you include deep water, we have 54 species of living, breathing modern sharks. And then when you go into like the coastal plain here, you have Miocene fossils of sharks. And then apparently when you go further inland, past the mountains into Kentucky, you have super ancient sharks. So I kind of love that sharks cover this land. Like, and not just here, of course, like pretty much everywhere, like everywhere almost in the world. Like where, there's fossil deposits of different ages depending on where you are. And it's so cool to think about, and like to think about the geological history of, these places. I mean, because it's like, I just think it's extremely cool that, we think of, because I don't know if I ever shared this, but I personally, I really don't enjoy being in states that don't touch water. I just, like, I feel like so disconnected, and I feel like, it sounds really weird, it sounds kind of like a little dramatic, but it's like, but it's true, it's a weird thing where it's like, if I'm like, in an inland state, I'm like, I don't want to be here. And yet, it's really cool to think about, like, Kentucky is a completely landlocked state, and yet there's a connection to sharks. It's so cool. Like, that even though Kentucky is not touching the ocean of today, it has this unique and amazing formation of prehistoric animals, prehistoric sharks. So Ooh, Pennsylvania has some big Adestus shark fossils. That is super cool. Adestus, if I'm not mistaken, is that the one with the scissor-like jaws? I think that is. Pennsylvania Adestus. Let's see. I'm very curious. There we go. Yeah. Let's check out Wikipedia, because sometimes Google could be a little weird. What a jaw. Man, what a jaw. Just like no modern shark like this. Like these kind of like almost interlocking, highly serrated teeth, you know, all like funneled into a forward shape. That is amazing. That is an amazing jaw. Tooth whorls. That is so cool. Let's see if I can get this image so people can see it. There we go. So that is Adestus. Scissor jaws, yep. Trying to make sure people can see it. Oh, this stupid arrow's in the way. There we go. Okay. Adestus, the scissor jaws. There we go. Do not want to meet. Oh, cool. I believe this is a holocephalon, so that would be a chimera. So that is really amazing. And actually, that's actually extremely cool if it is a chimera, because this one would be a weird one because the gills are exposed, whereas chimeras of today have that operculum covering the gills. So that's actually extremely cool. Oh, here we go. There's wow. This is map of the ancient world. Teeth for breaking ammonites. That is so cool. Oh my goodness. All right. So I love that this article is called "Sharks in the Dark," and I think again, and I posted in the chat. So this is a really cool dive into Mammoth Cave National Park. So please go ahead and check it out. I posted the link of this article in the chat. There's a lot of cool stuff in this, and Mammoth Cave is such an interesting site. So Sharks in the Dark, I think it's a great transition into tonight's species, the Pygmy Shark. So I'm going to make sure we can see some clips. So Pygmy Sharks are one of the few species that actually has bioluminescence. I'm trying to, I don't know, I honestly hate this eCam update. I don't know what happened, but it's kind of screwing up my display a little bit, so I'm going to ask them to patch it up a little bit. There we go. Okay, this is a little bit better. So, but yeah, the eCam update that turns my likes into dislikes and screws up my display screen. So sorry if there's like weird display issues. Let me know if I need to change anything. So, oh, baby, I love this. Imagine a movie called Scissors. Yeah, for sure. That would be great, and that would also take the focus off Megalodon. That'd be actually an awesome movie. So that'd be actually kind of cool. Imagine doing like a Jurassic Park. Actually, if you did a Jurassic Park but with sharks, you know, ancient sharks, like fossil sharks, that would be a winner. Because it's so much to draw from. That would be the raddest movie ever. All right. So we're going to take a look at shark bioluminescence in general, because the Pygmy Shark, which is, I believe, the world's smallest shark, which is going to be really cool. We're going to be doing... we've done the whale shark before, which is the world's largest shark. Now we're going to do the world's smallest. So we're going to take a look at some cousins of the Pygmy Shark. This is a close one, actually. This is a kitefin shark, Delacius licca. The Pygmy Shark is actually also a Delaciidae, so it is not a lantern shark. It is a kind of kitefin shark or cookie cutter shark. So it probably doesn't have the same habits as cookie cutter sharks, but it... as far as like the ring bite, as far as I know, but it is more closely related to that. So this is a really good shot of bioluminescence actively being displayed in a living shark. So you can see there's the little jaws right here, the little fins. Here's the jaws right here. This, I believe, is a lantern shark of some kind. So we'll go ahead and go back. This is another kind of lantern shark here. So lantern sharks, pygmy sharks, cookie cutter sharks, the viper dogfish, and I think there's a few more have this unique trait of bioluminescence. So I do want to like go back just to see how the shark moves underwater, and then we'll kind of go into the bioluminescence specifically. So these sharks are, there we go. So again, here's like the little pectoral fins. There's the mouth, just kind of like that vertical line right here. And it's so cool to see bioluminescence in action. Super cool. So I just want to take a moment to show that movement in life. And then here's kind of like a fun little model of bioluminescence in sharks in general. So these are, animations, but I think it kind of helps showing how these sharks do glow underwater. And this is probably the closest animation to the pygmy shark, which is the kitefin shark. This is Delacius licca. So this is Delatiidae. So this species, this is a close cousin of the pygmy shark. It's a larger example, example of that family. Yes, actually, yeah, Bibi, you're absolutely right. So cookie cutter sharks are a kind of kitefin shark. They are part of the same family. This one, the black-bellied lantern shark, is not in that family, but it is bioluminescent. But you can tell this is a lantern shark because it has spines on its near its dorsal fin. The kitefin sharks don't have spines. But again, this is really cool to see just kind of how the pattern works. It like the bioluminescence kind of works like a counter shading theoretically, where you see that's on the belly of the shark but not on the top of the shark. And then here is another kind of bioluminescent lantern shark, the southern lantern shark. So again, this is a shark that has spines on it. But for comparison, let's go back to the kitefin shark. See how the kitefin shark does not have spines. Similarly, the pygmy shark, Euprotomicrus bispinatus, does not have spines. Let me make sure it's in the same family. Yeah, there we go. It does not have spines. So, great question. Are all bioluminescent sharks small? Yes, I believe they are. Because I think there is I think there's a little blurb here. Okay, yes. So the answer is yes, because this is the kitefin shark, and it says this is the largest known vertebrate to emit bioluminescence. So the answer would be yes. I paused for a second because I believe that there are some sleeper sharks that may have bioluminescence, but that would be not the big ones. Like that would be, I think, the Portuguese dogfish, which is, is it the Portuguese dogfish? You know what? Let me double check that. Let's check out the actual main article on bioluminescence. Here we go. All right, because someone has bioluminescence. Here we go. Yes, Howard, absolutely. It would be cool if there was a large one, though. That would be awesome. And actually, I'm kind of curious if there's large bioluminescent invertebrates, like bioluminescent squid, potentially. So, let's see. Delicious and nice. Okay, so here we go. So Delicious is a kitefin shark. So that was like what we saw in that little video. Isistius is a cookie cutter shark. So these are bioluminescent. Mollusquama is a pocket shark. Euprotomicrus, I'm not sure what this is. Squaliolus, not sure either. Euprotomicrus is the pygmy shark. And look at this, the pygmy shark. Let me zoom in on this for a better view. Euprotomicrus is all bioluminescent. So the pygmy shark's entire body uniquely is covered in bioluminescence. So, and here it is in life. So this is the pygmy shark completely covered in bioluminescence. So I feel like for an animal this small and for the entire body to be covered, I wonder if this is kind of like camouflage. So it'll be interesting to learn more about this as we read more about the pygmy shark tonight. But check that out. That is so cool to see that the entire body is covered with bioluminescent pores. It's so cool. We've got, let's see, Zamius. I think Zamius is what I was thinking of. Let me double check if that's a sleeper shark. Zamius shark. The velvet dogfish is a sleeper shark. Okay, I knew that was, okay. So this guy, Zamius, is actually a cousin of the Greenland sleeper shark, and also the Pacific sleeper shark. So this is a small kind of sleeper shark, but it is in the same family, Somniosidae. You got Trigonognathus, which is the viper dogfish. That was an early stream that we covered, but that one is extremely cool. And then these are more like the classic lantern sharks. Centroskillium, let me make sure that is a lantern shark. Euptomopterus is our lantern shark, so all these down here are definitely lantern sharks. But let me make sure Centroskillium is one as well. Centroskillium. I think it is, but I just want to make absolutely sure. Eumopteridae, yep, so it's a lantern shark. Okay, awesome. So, yeah, so all these sharks are bioluminescent, but you can see that they're all pretty much small. Zamius is interesting because it is a sleeper shark. And I just gave myself a lot of work before realizing these little letters indicating the families. So D is Delatiidae, S is Somniosidae, and then E is Eumopteridae. So that's a shame that I could have saved myself so much work. So Delatiidae are the kite fin sharks. Somniosidae are the sleeper sharks, so it's only Zamius. And then Eumopteridae are the lantern sharks. So interesting. I thought bioluminescence is primarily for attracting other fishes to eat up or attracting mates or mating. So the cool thing is, that's a great question. The cool thing is it can be, depending on the shark. For sharks that have bioluminescence, often it is counter shading. So for example, all of these sharks are in the twilight zone or midnight zone, and so the first instinct is like, well, why would you counter shade because there's no light down there, right? And that would be correct, except remember, these sharks actually do diel migration, meaning that at night they will actually swim up to the surface in order to go after prey items. And when they do that, there could be a night where there's say a full moon and the water is somewhat illuminated. So the bioluminescence does help with counter shading. So if you're a predator, if you're a predator looking up at these lantern sharks and you're looking up at a dark blue sea, this coloration actually does help protect them from predators who are looking up and they don't see anything. Hatchet fish are similar in that way too. So I remember when I think Blue Planet did a special on bioluminescence. I remember it confused me because I was like, well, wait a minute, these animals live in a low light zone, so why would you need counter shading in a low light zone? And then I forgot that these animals, they do the diel migration, so they actually do go up to the sunlit zone at night, and they will probably see possibly see moonlight. So, but to your question, thank you. To your question, this study is a really cool study because it does talk about how bioluminescence functions in different ways. For example, Euprotomicroids emits a bioluminescent ink or fluid. Same with Mollusquama. This is the pocket shark. And it's suspected that these are for attracting mates. So let's check out Euprotomicrus, what its bioluminescence is used for. So let's see. Here we go. I'm going to zoom out for better reading. Here we go. And actually, let's do. Yes, that would be for the underside only. Yes, so that would be, and that would be it because if you are, the counter shading would work for the underside because if you are a predator looking down on the shark has these sharks have black bodies, and so a predator looking down into a moonlit sea, it's still going to look dark, kind of against the moonlight at the surface. So it will still look dark, and if you're looking downwards, the shark will still be camouflaged. But if you're looking upwards, where it's illuminated, the shark has to have the bioluminescent blue in order to blend in. Because if it didn't have that bioluminescence, it would be a black shadow against the moonlight. So if that makes sense. So it still works for counter shading, but I am curious about the pygmy shark, Euprotomicrus, if there's a specific function, because this one, the pygmy shark, is unique because the entire body is bioluminescent. So here we go. The pygmy shark, Euprotomicrus bispinatus. Oh, okay. Hold on. Is this just naming them? Let's see. Blue photophores? Okay. I have to kind of be a little pygmy. Small pygmy shark. Pygmy shark. Okay. Bispin. Okay. Spontaneous luminescence representative of shark species lateral view for. Okay. Okay, there we go. Okay, Amopterid and Delatiid sharks display a set of visual features not found in non-bioluminescent sharks, which strongly supports the idea that their visual system co-evolved with their ability to produce light. Aphakic gaps in Squaleolus and Euprotomicrus bispinatus and translucent upper eyelid found in Amopterid sharks probably play a role in counter-illuminating, for example, facilitating perception of downwelling light intensity to ensure the perfect match, similarly to what was recently shown for deep-sea bony fishes. So, okay, so this is like camouflage. On the other hand, the spectral absorbance, Amopterid rod photoreceptor, as well as retinal distribution and ganglion cells for the shark, appear finely tuned to detect their own bioluminescence, especially from flank markings. Okay. So not a lot of information on the pygmy shark specifically, but from what little it's saying, it is about counter shading. So let's say Delatiid. Delete. Hold on. Delatiidae. There we go. Okay. Okay. So I do want to check the family of the pygmy shark. Let's see. The Delatiidae family radiated later during the Paleocene after the Cretaceous-Paleocene mass extinction, where they substituted distinct marine reptiles and fishes in the apopelagic fauna before reaching the deep sea. Interesting. Interestingly, the photogenic structures appear ubiquitous in Amopteridae, so that's the lantern sharks, and Delatiidae, the kitefin sharks, including the pygmy shark. Interesting. This is a really cool phylogenetic chart of luminescence in sharks. So Amopteridae over here, the blue is like observed luminous species. The gray is like expected luminous species, so we haven't confirmed that these are bioluminescent, but it's likely that they are. And white would be non-luminous. So all the lantern sharks we think are bioluminescent. The sleeper sharks, there's only one species, that Zamia species, that's bioluminescent. Delatiidae, the kitefin sharks, including the pygmy shark, we think all of them are bioluminescent. So really, as far as bioluminescent sharks go, there are two big ones, two big groups, the kitefin sharks and the lantern sharks. Can you explain those numbers next to the circle? Yes, so these are the numbers of species. So this, for example, in this Amopteridae section, there's 52 total species. 9 of them are in blue, and that means 9 of them are luminous. They're confirmed to be luminous, so we've seen and observed them being luminous. 43 are dark gray, meaning that 43 are expected to be luminous. Like, we haven't observed it, but we're pretty sure that they're going to be able to do it. And then 0 are non-luminous. Like, there's no way they actually give off light. So when you compare it to here, Somniosidae, there's 17 kinds of sleeper sharks. One of them is luminous, and the others, 0 of them are expected to be luminous. There's no way. So 16 of them are confirmed to be non-luminous. So Delatiidae, the kitefin sharks, 5 of them we know are luminous, including the pygmy shark, and 5 of them we think are luminous. So I am kind of curious about let's see. I'm just gonna skim through the family Delaciidae to just kind of see. The second most widespread and well-supported function of shark luminescence is intraspecific communication. Although Delaciidae and Somniosidae present simple luminescent patterns where photophores follow the dorsoventral density gradient, Eumopterid sharks... Okay, so this is saying that lantern sharks actually could maybe communicate, but kitefin sharks, maybe not so much. So, let's see... So kitefin sharks and sleeper sharks harbor less complex and smaller light organs containing a single photocyte, and pigmented sheath in the group of small lens cells. So it's saying that lantern sharks are more complex. Oh, cool, Howard. I believe diet is linked to luminosity. Interesting. And that would be really cool because it's like there's so many bioluminescent animals. So there's like deep sea squid that have bioluminescence, lanternfish that have bioluminescence, or isopods or copepods, bioluminescent copepods, and probably a lot more. So, like, I mean, even like plankton, like on a planktonic level. So that's actually really cool. Let's see. I'm just kind of skimming through. Okay. I don't want to get into the weeds. Oh, they eat luminous jellyfish. Ooh, that's really cool. We have actually, I might have talked about comb jellies before, but we do have a, also known as ctenophores. We actually have comb jellies that are bioluminescent in the Chesapeake Bay. So, like on a summer night, if you kind of wave your hand through the water, or if you're like hauling like a net or something, you'll see this beautiful bright blue glow, which is so cool. So, interesting. For camouflage, gray is the best because gray works in most situations. Countershading only works from one direction. World War II bombers found this out the hard way, if my memory is right. That's an interesting point because what is the color of most shallow water shark species? It's gray. So that's actually a really good point, Bibia. For deep sea sharks, it's like, I think the black works because a lot of deep sea sharks are black or brown. Few of the deep sea sharks are gray, but the shallow water sharks, a lot of them are dominantly gray. And especially like here, like in temperate Atlantic waters, I mean, when you think about it, it's like you have great whites. I mean, all of them. Great whites, bull sharks, sandbar sharks, dusky sharks. I mean, all the recreational sharks, the hammerheads. Sometimes they can be bronzy, but most of them are gray. So it's a really interesting observation. So. I think that's all I got for this bioluminescent article. So I think what we'll do since it's already 10 is we'll dive into the pygmy shark specific. There's actually quite a lot of material on the species. So we'll do species specific notes on Euprotomicrus bispinatus, the pygmy shark. So this is the original description. Beautiful illustration actually. This used to be known as Skymnus bispinatus, discovered in 1842. So in the total pitch black, it doesn't matter because you can't see in the dark. That's true. It's kind of funny how they say, kind of related to that, they say that red is the best deep sea color because it's the first color to be absorbed in the spectrum. And that's true, but at the same time, it's like, well, I mean, all colors are gone at that. like once you're in the midnight zone, like once you're below 1,000 meters, all colors are gone. And even in the twilight zone, I don't understand. Like, it's like some light technically penetrates the twilight zone, but that is just so far down. So, but this is a really beautiful illustration of the pygmy shark, and extremely accurate too. So this is incredible to think. This is 1824. So 1824, trying to think of world events. Hold on. Let's see. 1824, just for comparison. Let's see what's going on. World events in 1824. Events. The first dinosaur is discovered. Megalosaurus was discovered in 1824. Lord Byron dies. The famous British poet, age at 36. The first Constitution of Mexico is ratified. Okay. Oh god, the first American fraternity is founded at Princeton. Okay, 1824. Weird year. So, oh, Howard, good catch. Megalosaurus turned out to be an iguanodon. Good catch. You're absolutely... So, I forgot about that. I forgot, because, like, iguanodon was the first dinosaur ever discovered. I forgot about that. So, that is so funny. Good catch. I used to pore over dinosaur material, and I really kind of fell out of it. Because I used to be really into it in, I would say, like, high school, and then I got more marine science focused. So, but I forgot about that. So, let's see. Oh, interesting. Red, deep purple red seems to work out below the 299 meters midnight zone. First dinosaurs were funny. They thought the strangest things back then. Yeah. Have you seen? Oh my gosh, I have to show this to you guys. It is actually really silly. Hold on. Mr. Incredible finds Spinosaurus. There we go. It's actually really funny. So... This Mr. Incredible meme, I'm sure you guys have seen it. I'm sure I'm probably going to get flag copyright, for this, but it's too funny not to share. So, but kind of to that point of things being constantly revised, and dinosaurs being constantly reevaluated. There's this really funny one about Spinosaurus, and how Spinosaurus's biology has been constantly revised. So this is, I don't know if you guys have seen the movie Incredibles, but this is like comparing the failure Spinosaurus designs with the modern ones. It's actually a really, really well done meme. But we've discovered that Spinosaurus is more of an aquatic dinosaur, and then this is just getting more and more ridiculous, and then eventually culminates in, oh, it's basically a seal, which is not accurate, by the way. Like this is not real. This is not real. It's just really funny. But yeah. Like elephant, seal, Spinosaurus. Anyway. We'll go back to bioluminescent sharks. But you're absolutely right, Bibia. They thought Iguanodon had a horn, was a nail, or spike thumb in reality. So, oh my gosh. Euprotomicrus. Here is a modern illustration of Euprotomicrus. I was a big collector of dinosaur material. Jurassic Park came out and priced me out of the market, so I'm invested in shark material. Interesting. Wow. Man, that's actually really cool. Howard, out of curiosity, do you still have dinosaur material? I'd be really curious. And honestly, sharks, like, awesome thing to collect, because, and what's kind of interesting about that is, like, shark fossils are rare enough to be unique and cool and interesting, but common enough to still, be collectible and actually, like, legal to collect. Whenever I do the shark fossil contests, and like whenever I mail shark fossils to the winners, I do have to declare on customs, what kind of fossil it is. Apparently, and I don't know if this is for the United States or if it's for Virginia specifically, shark fossils are 100% okay to ship and to collect and mail and everything. Sharks are great. They're totally fine. Mollusks are not okay. They are not legal to ship. which I found really fascinating because, like, for me personally, I'm a big shark person, and I'm like, I don't really care about, the mollusks. But apparently, this must be a Virginia thing. Apparently, the mollusks are a big deal where it's like you do not mail, ship, distribute, collect mollusk fossils, and I found that really interesting. I don't really know why that is, but I have a few dinosaur bones, but I have a large Chondrichthyan collection. Super cool. I think I've shown you guys. I have two main fossil collections. I have my collection, which is like the Virginia Miocene shark collection. So these are a range of species. My favorites are the white sharks. So I have Carcharodon plicatellus and Carcharodon hastalis. So these are two ancient kinds of white sharks that are larger than the great white today. So I'm really, really proud of those. So that's like one collection. And then the other collection was a gift from a friend from South Carolina. And these are like the prize fossils of either Megalodon or Carcocles anguistidens, also known as the Totus anguistidens. And these are the ones that I share with the community, where it's like, yeah, these are for like our contests, like our giveaways, because they're not fossils I collected, and they're so big, and they're so, actually I have some right here. They're just so big and they're so cool that I want to share them with you guys, because the ones that I collect in Virginia, they're a lot smaller, and they're, it's just different how they were acquired. But let's see, these might be kind of like, this actually might be a mini meg. So here's one. There we go. That's actually still a pretty big tooth. So I have these two major collections. I remember for one of the contests, Howard was a winner, and thank you so much for mailing me a fossil in return. I really, really appreciate it. I put that in my private collection, my Virginia collection. So that one is not going to be redistributed. That one is safe and sound. But yeah, these are the Cooper River, South Carolina megatooth fossils, and these are for prizes for our community. So which I really had a lot of fun with. I have a lot of fun with. So. Yes, I agree. Anything of scientific significance should go to a museum such as Associated Dentitions. I agree. It's like, let's see, and Baby made a really good point. Both are nice, but it's a shame when stuff gets away from science and locked up in a vault of a rich person instead of being looked at after. I definitely agree. It's interesting that my fossil collection, I want to hold on to, and I do, like my personal one, the ones that I collect in the field, I do want to hold on to, just because like shark teeth you're allowed to keep in this state, but I think once I achieve like a very old age, I probably want to donate it. And it's interesting, there are collectors here who, I can't remember off the top of my head, but there are a couple people who liaison through museums like the Calvert Marine Museum in Maryland, or Westmoreland State Park in Virginia. There are like private collectors who do work with museums, who actually sometimes are a resource for researchers. Like they're amateurs, but they're so well known that it kind of, they do kind of benefit the scientific community in some way. So it'll be kind of interesting. I think for my fossils, I want to hold on to them for now, just because like I love them. I do value them as far as like I know where they came from. But if there was anything massive, like extremely rare, like Howard said, like an associated dentition, I 100% agree, has to go to a museum. And also in the far future, oh, yeah, Howard. Yeah, that's how I feel too. I would be willing my research collection to a museum when I'm done with it. That's honestly how I feel too. Like, where it's like, and I actually have cataloged where these, actually, let me show you guys. Hold on. 1 second. Ouch. Okay. So, I don't know if you guys can see. So this is my. It's very simple, but it's effective. This isn't my organization system. I bought like this years ago. This kind of simple. It's like a tackle box, but I've labeled it where it's like you have Potomac River, Rappahannock River, York River, and James River. And each little box, I have a little sticker indicating the actual park a fossil was collected from. So that way I can keep track of where they were from and what the the formation is. Because the parks, all of them are in such a restricted area that it's pretty like easy to kind of trace like what formation. Specifically, it's the Yorktown Formation or St. Mary's River formations for me. But yeah, just as an example, here is one from, where are you from? This is Carcharodon plicatillus from Virginia. This is a ancient white shark. This one is from, where are you? I got the, Chip Oaks. That's Chip Oaks State Park. So, because I got that from the James River in Virginia. So there he goes. And then this one, it might be the same species in different dentition. It also could be Carcharodon hostalis. But these are some of the largest teeth I've been able to collect in Virginia. They're about larger than a quarter, so they're pretty big. I'm trying to think of, hold on. Actually, yeah, let's measure these right now. I have a ruler that is international. Kind of curious about this. Somewhere. Well, somewhere. I know I have one. I'll have to send a picture of my office on the chat because it is very sharky, and very disorganized, as you can imagine. Okay, I cannot find my ruler. I usually have one, but anyway. I guess for comparison, kind of against like my thumb, this is about the size of the tooth, so pretty beefy. So, and then and I would say the white shark teeth are probably the rarest ones that I have. Yeah, so, but I keep it safe and sound. Oh, thank you that you're able to spot the difference and know what species or genus I find impressive. Oh, thank you, Bibia. I really appreciate that. It's taken a lot of work. Modern sharks are tricky, and they're tricky to tell apart on a species level. Fossil sharks are whole other level. And honestly, I would say Howard is the expert in our community because Howard's able to kind of tell differences that I didn't even know existed. For me, it's taken a lot of work, and there's still a lot of work I have to do to kind of get to that. It took a lot of work to get to that point for the big fossils, and for the little ones, I still have a long way to go, to be honest. Just because the differences can be so subtle. Some of them, the differences between a goblin shark and a sand tiger shark from the Miocene era, I still can't really tell the two apart sometimes. So yeah, absolutely love that comment, Bibia. Awesome. Stories too, the T-Rex is strange and they're way sadder examples. Luckily, most people like you are like you and give scientists a chance to have a good look at things first. Oh, thank you. Yeah, and to Howard as well. So absolutely. So, but we'll get back to modern sharks. Thank you for the indulgence because it's fun to talk about. I love showing off my fossils and I have a passion for them, but it's a cool field. So, oh, Howard, that's awesome. I've been collecting for 55 years and still learning. Yeah, isn't that the best? Kind of the lifelong learning for anything in the natural world. It's just that's just the best feeling. Where it's always really cool to be to have a mastery and understanding of a subject, but knowing that there's still so much more to learn. I'm rereading Life in the Chesapeake Bay right now by Alice Lipson. And I read this book in college, but rereading it after exploring and adventuring, it's so many things are connecting now for me that I didn't realize before. And I love that lifelong learning process. So likewise with your fossil hunting, I mean, that's the best feeling. So yes, and Bibia, 100% agree. Brain is our best muscle. I 100% agree. So 100%. So, but yeah, here is a modern drawing of the pygmy shark. Really beautiful blue eyes here. And a lot of the deep water sharks, again, have those like reflective green, blue, like really pretty eyes. Key features, we have the first dorsal fins far back behind the pectoral fins. The dorsal fins are spineless. The second dorsal fin about 4 times longer than the first dorsal fin, which is pretty interesting. The first dorsal fin is actually tiny. It almost looks like residual. It almost kind of looks like, it reminds me of like an adipose fin in salmon, kind of like a almost useless kind of fin. So the pectoral fins, short, broadly rounded posterior edge. The snout is moderately long, bulbously conical. It's a very small shark, and the color is a uniform blackish with no dark markings. The caudal fin is nearly symmetrical and paddle-shaped. So it looks like with the size of this animal, like being very small, the pectoral fin seemed to stabilize it. The caudal fin absolutely seems to be the main propeller. And then the dorsal fins are just very like, you know, and I know for all sharks, the caudal fin is the main propeller, but it's just like, you know, as far as like surface area goes, the caudal fin is just so large compared to the other fins on the shark's body that you can see how much work it does, I guess is kind of my point. So, the only English name is pygmy shark. And let's see, ovoviparous with 8 young per litter. Size at birth between 6 and 10 centimeters. The maximum size is 22 to 27 centimeters. So, and it's kind of amazing to remember that sharks are still very large animals when you compare them to, like, you know, crustaceans, bony fish, which can have a planktonic stage. I think that's the biggest thing. Is like a lot of bony fish, even some large bony fish, they are plankton. Like they start out life as plankton, and even though this is the smallest shark in the world, this would be a titan compared to bony fish. So you know, it's like it's still a very large animal, which is kind of cool to think about, but. I do want to do a comparison, so centimeters to inches. Alright, so 6 centimeters at birth, it's a 2-inch shark. So that is extremely tiny. That's really cute, actually. That's very, very small. I can't even picture a shark being 2 inches at birth. And then maximum size is about 9 inches. So 9 to 11 inches, so not even a foot. So that's like, wow. There's famous photographs of pygmy sharks being able to fit in your hand, and it's actually really cool to see how true that is. And yet, it's amazing to kind of check out some of the images here. So here's a nice illustration of a pygmy shark as well. Still has some nasty dentition when you think of the proportion of this shark. Like the size of the teeth versus the body. Yep. Yes, the size of the pups and litter are big in comparison to the max size of the shark. Absolutely. You know, these are still very effective weapons, you know, for like small bony fish. That's actually a pretty nasty set of dentition where you have like these, you know, sharp, beautifully bladed teeth with kind of like what looks like almost like a secondary cusplet in the back. I am curious the way... So because this species is a kitefin shark, it is the same family, Delaciidae, and because the teeth interlock, I am actually kind of curious if these do the same thing that kitefin sharks do, and this is going to be really gross. But kitefin sharks can shed their teeth in one go. Like they shed all of their teeth at once and actually ingest the shedded teeth before replacing them with new teeth. It's a really gross thing that I didn't know that they did, and you know, their teeth are a unique interlocking shape that kind of allow them to be shed as one unit. So I'm kind of curious if these teeth, because they do have also an interlocking shape, I wonder if the pygmy shark does something similar. So it'll be interesting to see as we learn more about the species. Question, are the teeth serrated? It looks like they're smooth, but this is a little bit of a blurry image, so we'll have to keep an eye on it, but I think these are smooth. But look at the rows right here and how they're folded back. So nasty set of dentition. Even though it's a tiny shark, that's proportionally really, really, really nasty looking teeth. And actually, you see these roots right here. These do remind me of kitefin shark teeth. So I would not be surprised if this species, like the kitefin shark, like its cousin, maybe sheds its teeth and maybe all at once and maybe adjusts them. This is a great image. So this answers your question actually. So the teeth are not serrated, but this is a great image, a microscopic, or not microscopic, but well, actually, yeah. I guess this is like a kind of. This almost looks like an electron microscope. Great image of the teeth in magnified view, so you can see how smooth they are, and again how effective they are. They're definitely pretty nasty teeth for a small but mighty hunter. Alright, so let's check out IUCN Red List. So the pygmy shark is least concern. So it's great to see that this shark is actually doing perfectly fine. This is the world's smallest shark, and he seems to be okay. And it's actually really cool to see that this is a global species that likes warm water. So this is a shark that can be found definitely in the tropical zone across all oceans. It's kind of cool to see that it has an extended distribution in southern Australia and New Zealand. So this is actually definitely temperate water down here. Definitely getting into temperate waters in South America, Southern Africa, a little bit in North America too. The Carolinas are subtropical, Gulf of Mexico subtropical. Southern California is temperate. So, but her primary distribution of this species is tropical. So, let's see what we got here for assessment information. The pygmy shark is a widespread oceanic shark recorded from numerous locations in the Indo-Pacific and Atlantic Oceans to a depth of at least 1,500 meters. So definitely can enter and lives in the midnight zone. The widespread nature of records suggests that it is circumglobal in pelagic waters. It is one of the smallest shark species in the world, reaching 27 centimeters total length. Little is known of its biology, although it is reported to have a litter size of 8 pups. Its small size and epipelagic, mesopelagic, and bathypelagic nature precludes it from capturing most fisheries, and as such there is no apparent threats to the species. Population trend is unknown, although it is suspected to be stable based on limited catchability and widespread occurrence in oceanic waters. There is nothing to infer or suspect population reduction at this time, and the pygmy shark is assessed as least concerned. So that's actually really cool to see. And I'll explain why in a second. I'm just going to take a sip of my nice lemon herbal tea for tonight. So, I think I've mentioned this to Howard before. I don't know if I've mentioned this on the stream to Vivian before, but there is a very interesting idea. And actually a study. There have been studies in different ecosystems where large sharks, like tiger sharks, when they are hunted out, when they're removed from their system, their niche is vacant. And that niche is being replaced by smaller sharks. So, like in North America, if you have a decrease in sandbar sharks, that niche of sandbar sharks can be replaced by Atlantic sharpnose sharks, which are very small. And what is interesting about that is there's an idea that what if the future of sharks kind of scales down smaller? And I hope that doesn't happen. And I think overall that has been happening and may continue to happen. But that's not to say that we will lose large species per se. It's kind of more like the most successful survival strategy, if you look at the entire span of evolution in the Anthropocene, like the modern human epoch, a small shark tends to fare better than a large shark. It is more quick to reproduce. It is more quick to grow to its maximum size. More quick to have its pups. More resilient to fishing pressure. And it is interesting to think about. I think it's a really fascinating idea, and it was interesting reading this lantern shark assessment where there's literally nothing wrong with it as far as it's too small to be really caught in fishing nets. It's global. It lives in extremely deep water. There's really nothing wrong with this species, and it's kind of interesting to think about. Like, this might be kind of the pathway to success for sharks. Is like small size, quick reproduction. This shark is doing well. Sharpnose sharks are doing well. It is an interesting thing to think about because a lot of the large charismatic species are not doing well. Like basking sharks are endangered. Whale sharks are vulnerable. Last time I checked, that they might be endangered actually. Let's double check that. White sharks are, I believe, vulnerable. A lot of the big species are not doing well because all sharks, compared to other animals, sharks grow and reproduce very slowly. But it is interesting. Yes, staying small and or underground, deep water is a good strategy to survive extinctions. And you know what is interesting about that? And that's a great way to summarize it. What's interesting about that is we've kind of seen it with, the megatooth sharks are not here anymore. Like, Megalodon is gone. Like, Angustidians is gone. And actually, you can make a very good case. Well, we've seen it with megafauna as far as, like, mammoths are gone. What is it? Irish elk? Or great elk or giant elk? They're gone. Dire wolves are gone. There's a lot of large animals that are not here anymore. And for those species, a huge part of that is human presence. And so it is interesting to think about where it's like, is the future of sharks going to be scaled smaller? So like you still may have like some very large species, but yeah. Maybe interesting, but big animals survive in the fossil record more easily. And what's interesting about that is, and I'm actually not sure about this, but whale sharks are endangered, unfortunately, so that's really sad. But big animals survive in the fossil record more easily. So what's interesting about that is, do big animals survive more easily, or are they easier to find versus small animals? So pretty interesting to think about where it's like, like a T-Rex skeleton is very easy to find. But, not easy, but like comparatively, a T-Rex skeleton is quite noticeable. But what about something like Bambi Raptor? That might not be as easy to find. So I don't know. And that's an open-ended question because I actually don't know the science behind that as far as that paleontology goes. But it is interesting to think about, because I'm trying to think. So, so the two largest sharks, the basket shark and the whale shark, are endangered. Let's look at the great white. Because I am curious. I forget so the white shark is vulnerable, so that's actually not as bad. A lot of the other large sharks, dusky sharks, are endangered. Oceanic white tips are critically endangered. Bull sharks are vulnerable. Tigers, we gotta check tiger sharks. White sharks are vulnerable, so that's not as bad. Tiger shark. And actually, a counter argument, whales are doing. It depends on the species, but tiger sharks are near threatened, so that's actually pretty good. So, let's check out. I'm actually kind of curious. What is a blue whale? The largest animal on Earth. Blue whale. Blue whale's endangered. Okay, interesting. So. Oh, yes. Sorry. Yeah. Just like a comment. Yep. This is the IUCN Red List website. So this is a great go-to. And what's kind of cool is that different governments have different standards for endangered or non-endangered species. But this organization, the IUCN Red List, it's like the International Union for the Conservation of Nature. This is like the global go-to as far as like, okay, so what is really endangered, what's not, and they have so much. They don't have everything, but I think they have the most comprehensive, and it's fantastic for sharks, but they have the most comprehensive summaries of conservation status for many animals, and they almost have every shark covered, which is great. Sharks are a huge focus for the IUCN Red List. They categorize animals and plants as critically endangered. Actually, the worst is extinct. The extinction categories are extinct, extinct in the wild, or actually let me see if I can find this. Hold on, let's see. Assessment process. I wish it just gave me a summary of how things are doing. Okay, yeah, it's not gonna give me an easy summary, so I'm just gonna say it like so from worst to best. Oh, actually, well, there you go. Here we go. Okay, there we go. So the worst one. Okay, you can actually see this on this bar. Okay, so the worst one is extinct. Currently, there are no extinct sharks, thank goodness. But there's a couple that are getting close. There's extinct in the wild. There's no sharks that are extinct in the wild. Critically endangered is the absolute worst, and there are actually quite a few critically endangered sharks. So the famous ones are the oceanic whitetip, the scalloped hammerhead, the great hammerhead, the sand tiger shark, some of the angel sharks. There's a lot of species that are critically endangered. Endangered is bad. The infamous endangered species. Vulnerable is nearly endangered. Vulnerable is not good. It's like there's something going on with this animal that the biology is kind of like, pointing towards endangerment. Near threatened is not bad. It's just like okay, there's parts of this animal's biology that are not great for conservation. There's parts of this animal's biology that's not going to do well against human pressure, but it's not quite there yet. And then least concern is like bunnies. Like they're fine. They're totally fine. They're going to be fine. Everything's fine. So it's nice to see that with the lantern shark, it's fine. Like it's actually doing pretty okay. Compared to other shark species. Howard, to your point, I watched a podcast about Megalodon on the weekend. The latest research indicates that they were born at 10 feet long, and as such were in direct competition with adult great whites and other large Miocene species, contributing to their demise. Which is really, that's fantastic. And actually, thank you, because that's exactly it. Let me go back to Pygmy Shark. That's exactly it, where, in that case, the Megalodon was outcompeted by the great white because the great white could attain that size more quickly compared to the Megalodon, and was at 10 feet, a 10-foot great white is a more capable hunter than the newly born 10-foot Megalodon, that's super cool. I actually didn't know that. But it's a more fully capable hunter than a 10-foot baby Megalodon, and so that great white was able to attain that size more quickly than the Megalodon can attain its adult size, and the smaller shark ultimately won out. Like the great white ultimately outcompeted the Meg and drove it to extinction. Likewise, the sharks that are smaller today, they're faring better against the force that is human pressure, and so they may outcompete and outlast the larger sharks. So, and it is a really good example of, as far as evolution goes, and as far as survival of the fittest goes, fitness does not equal muscle or ferocity or power. Fitness is what is the most fit for the time and the situation. What is the most adapt to the environment. And in this case, in a world full of human fishing pressure and full of human influence, a smaller, more quickly reproducing shark is going to do better and actually be able to repopulate itself, and fare better against a human-influenced world than a large, predatory shark that takes forever to grow and, takes forever to mature. So we'll see. It's going to be interesting, and it's going to be really interesting, I think, to see, as humanity changes, as because like you think of countries like Japan that are actually having population decline. You think of like Western countries starting to kind of reach a weird asymptote where they're like not really. There's not a lot of population growth. African nations do experience a lot of population growth currently, so it is going to be interesting to see as the human world changes, you know, how that will affect sharks ultimately. Like, will we continue to, you know, increase in population as a planet on a human scale, continue to put this pressure on sharks and drive some species to extinction while the smaller species survive? Or will we kind of reach a weird asymptote and maybe even decrease in population, at which point some of that pressure eases off and the sharks maybe, you know, have a chance of kind of rebuilding, even the large ones, their numbers. I don't know. It's going to be really interesting to see, you know, as time goes on. So, further to that, they now believe Megs reach at least 80 feet in length, with a body plan more like a lemon shark than a white shark. Interesting. That is amazing. 3 meters is like half a great white. That is wild to think about. I can't even imagine that. That's actually really terrifying because the deepest I've ever dove so far is 44 feet. Let me see. I've got my handy dive computer on me right now. Let's see. So that's half a meg. That's actually ridiculous to think about. Yeah, the deepest I did was 13.5 meters. For diving, I like doing meters as opposed to feet, but let's see, 13.5 times 8.3. Yeah, that's 45 feet. So that is like, damn. Let's see. Yeah, it's shocking to think that like the deepest I ever dove is like essentially a little bit over half a meg. I can't imagine a shark that big. Let's see. In common people's perspective, sadly, I'm just reading your comment, Bibia. There are plenty of people who disagree with science no matter what. Yeah, and it's really sad. You know, so I'll just read this comment out loud. And I think the summary of your comment is, you know, people are. It depends on where we are. I will say for the United States, a lot of the general public, it's weird. Like the general public. The general public is honestly very strange because it's like, there is definitely a faction of people, and a very vocal faction of people who are doing what you're saying, which is like they're very speculative about science and they're very weird about it, which is kind of sad because it's like, I think the best analogy I have, thank you, Howard, without science we have no understanding of nature. The best analogy I have is like science is mechanics. You know, it's just science. All science is the mechanics of the universe. It is like, you know, you don't have to believe it. You don't have to trust it. It just is. It's just how the world works. And you can either like know it or not know it. So like, you know, like if my car breaks down, there's mechanics to that. And I could ask a mechanic to help fix my car, you know, and I could believe that the car will be fine without asking the mechanic to fix it. But that's not going to change anything. That doesn't change the actual mechanics of the car, right? So similarly, you know, you can ask a scientist to, you know, like hypothesize, theorize, work with other scientists to, you know, get into mechanics of the universe. And this is physics, this is chemistry, this is biology, this is what it is. It's just how things work, right? And you can not believe it, but it doesn't change the fact that it exists. It doesn't change the fact that like evolution is like a process or gravity is a phenomenon that exists. It just happens, right? So like, you know, it's weird because I do feel like, there is a populace of people. I don't know how pervasive it is in the West, at least. I know in the United States, there's definitely a very vocal populace of people who are weirdly speculative about science, right? But I genuinely don't know how many of them comprise a fabric of like everyday life in the country. And I know that sounds really strange, but it's just like, especially with everything that's kind of going on at the federal level right now, it's really weird because I do feel like at least half the country is on the same page as far as like the science, right? But I actually think beyond that, even in more right-leaning factions in the United States, you have people who kind of get it, and you have people who kind of know it, and at least should know it. But it's just like, at the end of the day, it's just mechanics. It's just like, just science is the way the world works. So all that to say, I do have a lot of faith, in terms of, like, which ironic choice of words. I have a lot of faith in people eventually, in society, eventually kind of like, okay, guys, we can only be ignorant for so long, and kind of like, it's disservicing everybody. It's disservicing us. It's disservicing the world. It's not really making anything better or making things go faster. It's like, it's hard to explain. It's just like, I feel like we've come a long way. Like when you look at global human history, when you look at like, evolution was controversial in the 1850s, and we've come an extremely long way since then. In the 1950s, there was pushback in the United States specifically. It was like the Scopes monkey trial, and we've come a very long way since then. So, sorry, I'm just kind of on a diatribe. Let me read these comments. So, Howard, absolutely agree. Without science, we have no understanding of nature. Our understanding may change over time as our methods improve, but still, you can deny, but it won't change. If you don't take medicine or shots, you can make other people sick too, and that's scary. Plus environmental denial, scary times. And I absolutely agree. I do absolutely agree with that. Where I hope I don't sound dismissive. I don't want to like underestimate the disinformation. I don't want to underestimate the delusion. So I really hope I don't sound dismissive of that. I kind of am more reaffirming of like logic is logic, sense is sense. Science is science, mechanics is mechanics, and you can deny and keep believing against it for as long as you want to, but eventually it just doesn't work, because it's literally ignorant of the universe. Like, you can believe gravity doesn't exist, but then when you base jump off a building, believing you're gonna fly, it's not gonna go well. And I think that's kind of my perspective on it, where it's just like, and honestly, it's evolution and science it's just a beautiful thing. Just like if you're a mechanic, who takes pride in like, seeing a functioning car or a functioning device and thinking that's really cool, similarly, it's like, it's a beautiful thing to see the inner workings of the universe and like, the planet and ecosystems. So, like, yes, the earth is not flat. Absolutely. Oh my gosh. Don't even get me started. I hate that became a movement, because it's just like, man, what are you guys doing? It's just, and sorry, I'm going to get fired up, because it's like, in a flat Earth, nothing works. Like, when you think about satellites and planes and sunsets, like, if you had a flat Earth, everything would be destroyed. Like, everything would not work. It's so ridiculous. So, I am just here for, just sharing science, sharing knowledge, sharing truth. I'm just here for the truth, man. And I know we all are, so cheers. Oh man, these are scary times, but we are going to, get through these all together, and especially since, honestly, like, I think it's very powerful for people to continue, like, learning and, like, even communities like ours, which is very small, I think it's a very powerful thing that we're all here together, having these conversations and talking about, the world as it is, talking about, sharks and their evolution and, shark science as it is. I think that's a very powerful thing. It's a small thing, but a very powerful thing, where it's like, we're in sync with just how the universe works. And it's really cool, and, who we influence in our lives and, like, the circles that we support, whether that is like, universities, societies, politics, people, like just groups, associations, volunteerism, whatever we do, I think there's a lot of power in the choices that we make and what we elect to devote our time to. And it's just the audio is cutting out. I'm like, sorry about that. But like, I
it's a very powerful thing to just kind of like you know. I mean, just problem the truth, and like to affirm the truth, and just to devote this time, that we all have together here, or devote that time to like reading books and papers and like supporting people who like get it, like as far as like I think it's really important. So audio conspires against us now too. Oh my gosh. So yeah, I tell you, if there was ever the one thing I said this. I said this like a year ago. Because like when AI was starting to like really become a thing, I was like, I think there was a part of YouTube that was freaking out. I was like, oh my gosh, are there going to be like fake content creators and stuff? And I remember I said the one thing, like, as far as like if AI was to use my image or anything, the one thing that you can tell if it's real me versus like a weird creepy robot me is soda. I can't drink soda. If I ever shill for soda, if I ever try to sponsor Diet Coke or something, like it's not me. It's a scam. So like, So anyway, it's 10:50, so we got to pick a shark for next week. But let me make sure I didn't. I'm so sorry. Like, well, I love these tangents because they are really important. But I want to make sure I cover the pygmy shark, and I want to let's check out an FAO summary, but also think about a shark for next week. So let me know any suggestions that you have in the chat. And I'm going to just shout out things that are unique about the pygmy shark, anything that we might have missed. So in the FAO guides, I think are really good. So here we go. Let's see. The pygmy shark is an epipelagic, mesopelagic, and perhaps bathypelagic inhabitant of the central water mass of the North and South Pacific, South Atlantic, and Southern Indian Ocean at water depths from 1829 to 9,938 meters. Pygmy, not pygmy, I should remember that. Actually, what's kind of funny is, so pygmy shark, this is the FAO official English name, but depending on the country, it could be spelled a different way. So is this still same website? No, this is different. This is actually really cool. This is the FAO. So this is the Food and Agriculture Organization of the United Nations. So this is different. But the Food and Agriculture Organization of the United Nations actually does these really cool shark guides that are regionally specific. So you can actually learn more about sharks from a certain region. It's super cool. Howard, blackmouth cat shark. I actually think we did that, but we could do a cousin of that species. So let me double check. Let's see. Where is my channel? Okay. That's a really good suggestion. I think we did cover that. So I'm going to check the Carchariniform playlist. Let's see. Black tip reef shark. Swell shark. Okay, yes, we did do the blackmouth cat shark, but let me find a cousin of that species, because I think a new cat shark would be really cool to do. Let's see. Okay, so it's Galeus. So let's see. We've got the Antilles cat shark. Might be kind of cool. Yeah, let's actually... Let's see. You know what? I don't think we did that one. So, what we could do... Let's do a cousin of the blackmouth cat shark called the Antilles cat shark. Galeus atilensis. So this is a close cousin, I believe. Is this in Florida? Straits of Florida, Hispaniola to Martinique. So this is a Caribbean species. So I think that'll be a fun one to do. So let's do Antilles cat shark. Galeus antiliensis. Oops. Or antillensis. So that'll be kind of fun, because it's still it's spring now in Virginia, but it's still kind of like clammy and chilly. So it'll be kind of cool to go to a tropical area of the world. So yeah, next week we'll do the Antilles cat shark, Galeus antillensis. So awesome. But and thank you for suggesting a cat shark. This will be a close cousin to the blackmouth, since we did do the blackmouth. I think that was, I can't remember if that was last year or 2 years ago, but this one I think will be a cool cousin. And it's a really pretty species too. So. But we'll catch up on pygmy shark facts. Let's see. The pygmy shark is an epipelagic, mesopelagic, and perhaps bathypelagic inhabitant of the central water mass of the North and South Pacific, South Atlantic, and Southern Indian Ocean. 9,000. That can't. Wait a minute. At water depths from 1829 to 9,938 meters, I actually think that's a typo. Because that's actually kind of insane. Hold on. Let's see. Oh, here's another one. 9,938 meters. That cannot be right. Let's see this one. I don't think that's right. Because you're talking about, like, the Hadal zone. That's... Wow, wait a minute. Hold on. What does Ice and Redless say? 1,500 meters. So that's very different. What does this say? 1,800 meters. Yeah. Yeah, I agree, Bibia. I think that is a typo, because you're talking about a shark that is going to hell, basically. Sorry, so like let me see what the Hadal zone is, named after Hades. Hadal zone. 6,000 meters, and I don't think there's ever a shark that has ever been found in the Hadal zone. You know, because I believe the deepest shark is about 4,000 meters. So, and there's only so many places that enter the Hadal zone, which is really cool. The Hadal zone is super cool, as far as like it's a unique kind of deepness that is named after Hades, or the underworld. And there's only so many places that are that deep. It's incredible. So I think it's a snailfish. So it is incredible that there are vertebrates in the Hadal zone. But I don't think there's any shark that could go down that far. I believe the lower depth limit for sharks is 4,500 meters. So lower depth limit for sharks. Let's double check that. They're almost entirely absent below 3,000 meters. Yeah, so it's just like... The deepest confirmed reports of a shark, Centroscymocela lepus, 3,700 meters, and the ray, I don't know if it's Rhinoptera bigelowii, 4,100 meters. Yeah, so that, yeah, Chimera does 6,000 maybe, and that is very deep. Yeah, so I think you're absolutely right, it's a typo, which is really a shame, because it's clearly replicated over and over again, and that's not correct, so... I have to kind of side-eye this, which is really sad. Unless it's saying... I don't know if it's saying that the body of water that they're in is over 9,000 meters, like 10,000 meters, or if it's saying it would descend to that. So, let's see. It occurs at or near the surface at night, and apparently... And this is actually really cool. That relates to deal migration, which we were talking about. It occurs at or near the surface at night and apparently descends to at least mid-water depths to probably well below 300 meters during the day. Sand grains in the stomach of one specimen suggested it may have been feeding on the bottom, presumably below 1,800 meters in depth. All known specimens have been caught at the surface at night, while none have been taken in mid-water trawls at night or during the day. This is also suggests that the deal migrations of this little shark are enormous, at least 1,500 meters or more each way, to put it below the normal range of midwater trawl hauls in the day. In human terms, this would be roughly equivalent to someone climbing at least 11 kilometers up and down each day. Wow. Oh my gosh. Wow. Oh my gosh. So, let's do kilometers to miles. I'm kind of curious about this now. kilometers to miles. 11, so 7 miles basically. So that's actually really amazing. And I'm going to say this is probably not the best analogy, where a better analogy would, and it's still amazing that this shark does this. A better analogy is a human being walking, what is that, 7 miles? Oh, actually, wait a minute, no. Actually, no, that's still really insane, because a better analogy is a human being walking 7 miles back and forth each day. And that is actually really insane. So never mind. Sorry. This is actually truly a mighty species. That's actually incredible that this little shark can do this. So that is so cool and so wild. And I'm curious if like maybe what's kind of cool to think about is maybe this shark. This sounds kind of dumb, but we think of sharks on a horizontal level, where it's like we think of sharks swimming across the oceans in their day-to-day habits, right? And what if we think of this species on a vertical level? And what I'm thinking about specifically is kind of like oarfish. Like oarfish are famous deep-sea fish that their natural state is actually vertically oriented. It's not horizontal. And I wonder, given the unique body shape of the species, I think Bibia, you pointed out earlier that the first dorsal fin is virtually non-existent, that maybe this shark kind of like swims vertically in the water column, descends vertically in the water column, and maybe doesn't really spend a lot of time swimming across. And what's interesting about that is, remember that this shark has photophores all around its body, so it's not really doing the counter shading the way the lantern sharks or other kitefin sharks are doing, because the other kitefin sharks are swimming horizontally, and it has the counter shading. They have the counter shading on the belly, but this shark, what if it does? And I'm just kind of hypothesizing, but like, what if this shark swims vertically, and because it does that, because the dorsal fin is so small, the pectoral fins are the stabilizers, and the entire body is covered in the photophores. Let me see if I can get that study back. Where is it? Because I had it. I didn't X out, did I? Where is this? Okay, this is it. Glow on sharks. Okay. For comparison. Okay. Oh, here we go. Okay, so this is actually really cool. This is a good chart of how the sharks use their bioluminescence. So pygmy sharks definitely do it for camouflage. But look how, again, the entire body is covered in it. Whereas the other sharks, so maybe it is, maybe that does work for like if you were, but then again, I don't know. Because like, how would that work with counter shading? I don't know. I'm now that I think about it, I'm like, maybe that doesn't make any sense. Cause I don't know. Because if your entire body is covered in bioluminescence and you're swimming vertically in the water column, you know, will you be able to camouflage in the water? You know, does that help or does that hurt? I don't know. It's a hypothesis. It's a genuine hypothesis. It is genuinely an open-ended question. So, but I'm very curious because it's like of like this whole idea of vertical movement, because it is undertaking such massive migrations throughout the water column, and that is an unbelievable distance. So I'm actually not sure, but that is truly a phenomenal animal. And I do think the pygmy shark deserves the credit of small but mighty. But Howard, maybe it's hiding amongst luminescent plankton. That is a great point, because luminescent plankton would be kind of like, you know, once they're this. That's actually an excellent point, because if you bump into luminescent plankton, you do set them off and they glow. So if this shark is kind of careening through the water column and setting off luminescent plankton, it could kind of create in a weird way like a camouflage. Like kind of like a smoke screen, if you will. That is super cool. But yeah, deep water sharks are the best. Like as far as like, let me make sure. I hope I share this study, but let me make sure I put this in a chat in case anybody wants to read it, because this is one of the best shark studies I've ever seen. It's super cool. So, but yeah, we got one more. I just want to double check this illustration. I think we'll wrap up for the night. It occurs at or near the surface at night, so the pygmy shark is at or near the surface at night, and apparently descends to at least mid-water depths during the day. And that's really it on this species. I think we do have another really cool illustration by Mark Dando, so very famous shark illustrator, and this might be actually a good place to end. So let me make sure I didn't miss anything. No, because I think that's an IUCN Redless assessment. That's the same thing. So I think we'll end here. Oh my gosh. Well, this is a really cool species, and I know we didn't spend a heck of a lot of time on it, but it is unique amongst the sharks, where that tiny dorsal fin, the really sharp teeth, the incredible vertical migration through the water column, and the unique pattern of universal bioluminescence, if you will, like covering the entirety of the body. I think this is an amazing species, and it's actually really amazing and reassuring to see that it is actually least concerned. So this pygmy shark is a winner as far as shark evolution goes, and as far as combating the what do you call it, like human influence. This is a winning strategy. Being a very small shark living in deep water. It seems to be doing okay. That's actually one of the best assessments I've ever read as far as a shark that seems to be relatively unfazed by human pressure. So, and it's not completely. Pygmy is the smallest. I believe it is. I think there's another species that sometimes vies for it. It overlaps, but it definitely is the small shark, and you can actually. If I was to tell somebody, if somebody asked me what's the smallest shark in the world, I would point to this species, Euprotomicrus bispinatus, the pygmy shark. So I think it definitely well deserves that title of smallest shark in the world. So, but yeah, it's a really cool species, with a really unique biology as far as doing these massive migrations with the bioluminescence covering it completely. And a lot more to discover on it. So I think it's just a really, really cool pick for tonight. So thank you guys for suggesting it last week. And thank you guys both for watching. Really appreciate having you guys here to tune in for this stream. And I loved all of our topics because I really appreciate that we went into Mammoth Cave and prehistoric sharks. Had a really good conversation about science, evolution, and conservation. And that we were able to talk about the pygmy shark specifically along the way. So, but hope you guys have a great rest of your St. Patrick's Day. It's not over yet, so there's still time to celebrate. And hope you guys have a great rest of your week. And thank you for your feedback on potentially changing the schedules. I think we will probably keep the Monday night streams, but if there's any changes to that, I will let you guys know. And I'll put that on the community page. But thank you guys for watching. Tune in next week for the Antilles cat shark. I think it's going to be an extremely cool species to cover, and it'll be fun to go to a tropical area to kind of revisit clear waters and see kind of what the species is doing there. But hope you guys have a great rest of your week, and we'll see you next week for the Antilles cat shark. Cheers, and happy St. Patrick's Day, guys. Bye.